Okay, these are solutions to the first quizzes. Hopefully this is helpful to you. All right, for each of the circuits on the right, compute the power. And remember, if we have a passive sign convention, then the power is equal to positive VI. And if it's non-passive sign convention, then the power is equal to minus VI. Okay, so passive sign convention is when the current flows from the positive terminal to the negative terminal. So that's the case in this first drawing. So the power is going to be the voltage times the current. It's going to be a positive voltage times the current. The voltage in this case is 5 volts, and the current is minus 4 amps. So we have a minus 20 watts. So this would be minus 20 watts. And when the power is negative, then that means that we are generating energy. So this would be generated energy. Now in this particular case, the current flows from the negative to the positive terminal. So this is non-passive sign convention. So the formula is going to be power equals minus V times I. So this is going to be negative. The voltage in this case is minus 6 volts. So in determining positive sign convention, I'm just paying attention to the current direction and these plus and minus labels, okay, not the actual value of the voltage. So minus 6 volts times 2 amps, and this would be now positive 12 watts. So positive 12 watts. And since P is greater than 0, then that means that we are absorbing energy. Okay, in this particular case, the current is now flowing from the negative terminal to the positive. So this is non-passive sign convention. So P is minus V times I. And so we're going to have a minus. Now the voltage is a negative 7 volts. And the current is 3 amps. So this is going to be positive 21 watts. So positive 21 watts, and power is being absorbed because P, again, is greater than 0. In this case, current is flowing from the positive terminal to the negative. So this is passive sign convention. So the formula is power equals positive V times I. The voltage in this case is 9 volts. The current is 2 amps. So this would be 18 watts. So positive 18 watts. Power is positive, so it's being absorbed. All right, so the second problem here, using Ohm's law, find currents and voltages below. Pay attention to the directions. So remember, in a resistor, okay, if I have a resistor R, and we label the voltage like this, and the current flows from positive to negative, then V equals I times R. Okay, if the current flows in the opposite direction, it would be from negative to positive, V would be negative I times R. Okay, so we can also solve for I, and I is going to be equal V divided by R. Okay, so this first problem here, current flows from positive to negative voltage. So I is equal to positive V divided by R. And we've got a 20 volts divided by 5 ohms. So this will be 4 amps. 4 amps. Okay, now in this case, again, current flows from the positive terminal to the negative. So this is passive sign convention. So V is equal to I times R. The current's going to be 3 amps. The resistance is going to be 6 ohms. So this will be 18 watts. Volts. 18 volts. Positive 18 volts. Okay, now in this third problem, the current is flowing from the negative to the positive. So you would assume that, and because there's a voltage here, and the current flow is in the opposite direction of the voltage, we expect to get a negative current, because current and voltage are always related, by going positive. A current flow through resistor creates a positive voltage in the direction of the current. So the I here is going to be its non-passive sign convention. It's going to be V divided by R. And that means we're going to have a minus 20 volts over 4 ohms, so minus 5 amps. Okay, and here we've got current flowing again from the negative to the positive. So this is non-passive sign convention. So V is going to be equal to IR. And so we have a minus 5 amps through 3 ohms. So this will be a minus 15 volts. Okay, so now we've got the circuit shown below. We need to fill in the blanks. So this is our little game. So we'll go ahead and label all of the voltages and currents that we know. So the voltage across element A, here's going to be 5 volts. The voltage across C is going to be minus 6 volts. And the voltage across D is going to be 1 volt. And then the current through A, well, actually, let's just worry about voltages here for a minute. Maybe I'll use different pin colors. Okay, so in this particular case, the easiest way to sort of figure the voltage is to assign voltages to different nodes. So these voltages are just the voltage that we show here in green, are just the voltages across a particular element. So where we assign to be 0 is somewhat arbitrary. So I'm going to pick maybe a location that you didn't pick here, just to show you that you should get the same answers. So let's call this 0 volts. Again, that's an arbitrary label, but we do know that this point here is 5 volts bigger than that point. So if this is 5 volts higher than that, and this point here is 0 volts because it's the same branch here, then the voltage at this node here needs to be minus 5 volts. Okay, now if that's minus 5, we know that this point is 1 volt higher than that. So the voltage here must be minus 6 volts, because this is going to be, that would be minus 5 volts. If this is minus 6, then we have a 1 volt. The voltage across D is 1 volt higher on the positive side than it is on the negative side. Again, the voltage at this location is going to be minus 6 volts higher than at that location. And so the voltage, because it's minus 6 volts higher, this is going to be so this will be minus 12 volts. So minus 12 volts, and then we add to it a negative 6. Yeah, as we drop, we'd subtract from it a negative 6. So this would be minus 6 volts. So again, we just think of VC as without worrying about the signs. This has to be VC higher than that point. So this location, another way to think about it, it's going to be minus 6 volts, and then we have to add to it VC because it's VC higher. And since VC is minus 6, then that's a minus 12 volts. So this location must be minus 12 volts relative to that location. And so we know that this location is VB higher than that. So VB has to then be 12 volts. So that this location, which we've arbitrarily labeled as 0, and given that label, we end up with minus 12 here. VB has to be 12 volts. Okay, now we can, let's see, we also need VA. So VE, so this voltage here is VE higher than that voltage, which is negative 6 volts. So, and since this is 0 volts, VE has to be a positive 6 volts. So this would be 6 volts, like that. Okay, now let's go in and label all of our currents. Maybe we'll label the ones we know in red. So the current through A here is going to be 1 amp. The current through C here is going to be 3 amps. That means 3 amps flows all the way along that direction, and 1 amp flows all the way along that direction. Okay, so since IB here is flowing in the same direction as IC, and they have to be the same current, then IB is going to be, IB has to equal IC, which is 3 amps. So IB is going to be 3 amps. And then we know, so let's see, we also need to know ID. ID, though, has to be this. ID is in the opposite direction of IA, you see. And so since 1 amp flows in this direction, ID has to be a -1 amp. All right, so we have 1 amp going in that direction. We have 3 amps going in that direction. So this has to be 2 amps, so that the amount of current flowing in has to equal the amount of current flowing out. So this IE then would have to be 2 amps. Okay, now passive sign convention means that current, the direction of the current, I, is in the direction of a plus or minus, it goes in the plus and out the minus. So we can look at, this is passive sign convention, and non-passive would be the current going the other direction, non-passive sign convention. Okay, so we just have to look at each of these. For A, current flows, from negative to positive. So the answer is no. For B, the current flows from positive to negative, so the answer is yes. For C, the current flows from positive to negative, so the answer is yes. For D, the current is flowing from positive to negative, so the answer is yes. And for E, the current flows from negative to positive, so the answer would be no. Okay, now if it's passive sign convention, the formula for power is positive VI, and then non-passive sign convention, power is equal to negative VI. Okay, so since the answer is no, the power is going to be negative V times I. Since it's yes, it's going to be positive V times I, so we're going to have 36 watts. Since it's yes, it's going to be a positive V times I, but V is negative, so this would be minus 18 watts. Since it's yes, it's going to be a positive V times I, but I in this case is negative, so we get a -1 watt. And since it's no, the power is negative V times I, so minus 12 watts. Okay, now when the power is negative, we're supplying, so power less than 0, this is supplying power to the circuit. When the power is positive 0, we're absorbing. Okay, so positive here means absorb, negative means supply, negative means supply, negative means supply. Now we should, by the way, all of these should sum, all of the powers here should sum to 0. So let's see, do they? Let's see, so 18 plus 12 is going to be 30, plus 1, 31, plus 5, so 36. So we have a plus 36 minus 36. So the sum here is equal to 0 watts. So we did this correctly. All right, last problem using Ohm's law. Ohm's and Kirchhoff's law, analyze the circuit below. So we know from Ohm's law that, and this is passive sign convention, so I is flowing from I to V, so the voltage is going to be equal to I times R. So in this case, V is going to be equal to 6I. Okay, we know that that's true. Now we need to figure out what I is. Now the easiest way to figure out I is to notice that this circuit is equivalent to the following circuit, 24 volts, and then we're going to combine, you see, these two resistors in series. So this is equivalent to a resistor in series. Since they're in series, the R equivalent is going to be 4 plus 6 equals 10 ohms. So this is like having a 10 ohm resistor. The same current flows through both of them, and that is I, and then this is a positive to negative V. Okay, so we know that this particular voltage here across the equivalent resistance, that has to be, I'm sorry, so let's not call it V, let's call it, partial, and, sorry, so this is an R equivalent, and let's call this a V equivalent. So that V equivalent, the voltage here has to be the same, as the voltage here, which is 24 volts. So this is 24 volts. So the current then is going to be V equivalent divided by R equivalent, which is 24 divided by 10, which is equal to 2.4 amps. So we know that the I here is positive 2.4 amps, and now we can go back up here to our formula and say V is equal to 6 times 2.4. So let's see, 2.4, 6, 4, 2, 14, so that's equal to 14.4 volts. And that's the solution to that one.